Tim, talk to me about this journey of philosophy. And I mean, today when we think about science, we think about the fact that it's very pragmatic, very practical. And a lot of scientists tend to disregard what philosophers have to say. So I want to know from you, does science need philosophy?
Well, I mean, I'll start with an observation that I always make, which is that all those people in science departments in universities, they all hold doctorates of philosophy, right? So they are, I mean, officially they are philosophers. Why is that? Because philosophy is just by definition the search for wisdom or knowledge, right, or understanding, which people do in all sorts of ways, hopefully in different departments, using different techniques. So do you need philosophy? Well, if you're not interested in knowledge, if you're not interested in understanding, you're not in business as far as I'm concerned. Then, what's left in that, what they mean, of course, is do you need what people in philosophy departments do? And of course, Newton was a natural philosopher, right? I mean, he would identify himself as a philosopher, and Descartes and Leibniz and, all of these people who were very important in the history of science would identify themselves as philosophers. But as those different disciplines became more self-sufficient and more specialized, they got shunted off into different places in the academy. And then the people left in philosophy departments are just the leftovers who sort of didn't have anywhere else to go. But that includes lots of people. I mean, I'll just take as an example, David Albert over in Columbia is in the philosophy department. His degree is in theoretical physics from Rockefeller University. Why is he in a philosophy department? Because he was interested in questions of physics that physics departments are no longer very interested in. And he could pursue those questions better in a philosophy department. I mean, my own degree, highest degree is history and philosophy of science. It's not actually a philosophy degree, if you will. Is it surprising that I am interested in science and maybe have some intelligent things to say about it? Not from my background and my training. When you say that physics today is very practical, that suggests, first of all, it suggests one thing, and second of all, in a certain sense, it isn't true at all, okay? So the thing it suggests is that all of physics has just become a branch of engineering, right? That the only reason one pursues physics is because at the end of the day, you get toaster ovens out of it. And, that would be awfully sad. And then they should just stop calling them physics departments, as far as I'm concerned, is, say, okay, we're going to move you over to the engineering school. And the second thing is it's just not true at all. I mean, for 50 years, high energy physicists have been trying to figure out this thing called string theory. Does it have any practical applications? No. Could it ever conceivably have any practical applications? No. Is it likely to even be correct? That turns out to be no, too. That's a different issue. But even if it were correct, it's not going to give you a better toaster oven, right? So it's just not true that the primary motive of even what's done in physics departments is practical. The problem is the purely theoretical part, the part that is aimed at simply understanding the physical world. That part has been neglected in physics education for over half a century, probably more than that, for funny historical reasons that have to do with quantum mechanics. So the sorts of questions that Einstein would have been asking all the time and Schrodinger was asking all the time have been kind of kicked out of the physics curriculum. And those of us who are interested in those questions find that a tragedy, and we find somewhere else to ply our trade, because what else can we do? It's just, you can't make a living in a physics department caring only about understanding, in the kind of understanding that was standard, the sort of thing that Maxwell worried about, the sort of thing that Boltzmann worried about. It's just not, it's not considered proper in most physics departments. Although I have to finish that by saying my sense is it's getting better. My sense is that things are coming back after a long dry period. And physicists are more interested in purely questions of what does it mean to understand something? How should a well-formulated theory be presented, or how should it be formulated, and things like that, and what counts as an explanation? All sorts of questions that get into more philosophical territory, if you will.
I think you're absolutely right. I think that's, I mean, particularly with platforms like this, podcasts, I mean, we have this opportunity to dissect certain physicists' theories and talk about it. And it opens up the platform for the layman, let's say, to ask questions that perhaps some scientists don't really think about in the day-to-day, because more often than not, we're all placed in these normative values that we go through life engaging with. And we don't really realize that we place value judgments to everything we do. Do you think it's...
Yeah, I mean, I have to say my experience in physics, and a lot of people's experience in physics, isn't that it's quite as unnoticed, as insidious as that. There's this phrase that either Feynman or David Merman came up with, shut up and calculate. And I know from my own personal experience and from many other people's experience and from my students' experience that they confront this in physics departments exactly when they want to raise the sorts of questions that I've been talking about. What's really going on? What really is an electron? I mean, do electrons really orbit? I mean, what are these kinds of questions? They're physics questions, and they raise them in class, and then they're told, shut up and calculate, right? I'm going to give you a method for making predictions about outcomes of experiments, and that method involves solving a bunch of equations. Now learn to solve the equations. And they're upset about it. They don't like it. They come and take classes in philosophy of physics in the philosophy department because they don't like it. And they say, gosh, this is what I was interested in. So I don't think it's quite as insidious in that. I think that it's a source of immediate frustration to many, many students. Eventually you get worn down. Or eventually, maybe there's a sorting process that if this is really what you care about, you just abandon physics because it's not addressing the questions you're interested in. But I think my sense is that many physicists harbor this sense of unease about the way physics has gone, and are actually quite happy when you come and talk to them about these questions in a straightforward way.
You were drawn particularly to the philosophy of physics. Is that because of this innate curiosity to figure out the fundamental nature of reality down at its core?
Yeah, I mean, as I said, I think that's true. You have to be a little careful when you say it, because it could be misconstrued about what you mean by fundamental. Because, and unfortunately, again, there are all these memes of the arrogant physicist who says, oh, chemistry is just applied physics, and biology is just applied chemistry, and neurology is just applied biology, and psychology is just, and everything is really, 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 really physics. I think that's unfair to the other disciplines. I don't think that's appreciating the structure of the kind of understanding and explanation you get out of something like chemistry or something like neuroscience, or economics. I mean, yes, you need a physical world to have an economic system, but really, honestly, figuring out whether it's string theory is not going to make a dime's worth of difference to economics. But there is a sense, right? There is a specific sense in which, yes, chemical behavior arises out of physical behavior and not the other way around. The way I often like to say this is there's this, I mean, you may know this wonderful Tom Lehrer song about Wernher von Braun, where he says, that's not my department, said Wernher, right? The rockets go up, who cares where they come down? That's not my department, said Wernher von Braun. The thing that's special about physics among the empirical sciences is that every phenomenon studied by any other science is also a physical phenomenon. Right. Now, you may not be studying it as a physicist, but it is a physical phenomenon, right? And therefore, again, there's a stock market crash and you're an economist, you're trying to figure out why. Well, that stock market crash, which involved a bunch of people pushing buttons and selling stocks, that was a physical event. And therefore, in principle, it falls under physics. And the physicists can never, every other department can say of some things, that's not my department, right? I mean, the economist says, look, there was a big problem because of these droughts. And then you say, but why did the drought occur? And the economist says, I don't know why the drought occurred, right? Go talk to the climatologist. That's not my department. That's not what I deal with. And physicists never have that out. Because everything is a physical phenomenon, in a certain sense, they have to be able to handle it. Theoretically. In that sense, in a very specific sense, I think physics is the most fundamental of all the empirical sciences. And therefore, if you're interested in that kind of fundamentality, you are drawn to physics. And that's why I think there are more philosophers of physics than there are of other sciences, even though there are a lot of philosophers of biology and some philosophers of chemistry and some philosophers of economics. Other sciences have their problems and their issues and need to be understood. But most people, I think, at this point, in a specialized field in philosophy of science, are philosophers of physics.
I think with that background in mind, how would you define matter, Tim?
Well, that's so one thing you learn real quick if you have a philosophy education is that how do you define X is often just a trick question. It's really hard to define anything accurately. I mean, Plato, Socrates figured that out. How do you define virtue? How do you find right? And then he keeps poking holes in it. I don't think definition is quite the right word for here. We have unquestioned examples of matter, right? I mean, this gadget I'm holding in my hand is matter. And in fact, my hand is matter. And in fact, anything that is in space and time and moves around in space and time is sort of material. Now, even there, you're getting you can get on the edge and people say, well, what about electromagnetic waves? They're in space and time and they move around. Are they matter or not, right? And then you could get into a little kind of pointless semantic debate over it. But we have these examples of what we know absolutely we treat as matter. And you can sort of think, and that involves, solid objects, gases, stuff like that. And then you're in the game of trying to explain how they behave. And then physics can postulate new things in service of that explanation. That's how we got electromagnetic waves, because we started with things that are clearly matter, like wires, right? Voltaic cells. And then you say, gosh, these voltaic cells and so on, they're doing interesting things. It turns out I can explain that or account for that much better if I postulate these things called electromagnetic waves. And that's my reason for doing it. Now, the question that then came up at the time, quite honestly, and can come up is, yeah, but do they count as matter? I think at that point you should just shrug and say, I don't care. Call it whatever you want. The theory postulates there is this, there are electromagnetic fields. Are fields material? That's just, as we say, that's mere semantics. If you believe in them, if you think, gosh, I have good reason to believe there are such things, and I have good reason to believe they behave in such and such a way, then who cares whether you call them matter or not? At the end of the day, your only reason for believing them is the effect they have on things that are unproblematically matter. The vibration in a radio speaker, that's clearly a material, the speaker is material, and the vibration that gives the music out of the thing, right? That's a material motion. If at the end of the day, to account for that, you have to postulate electromagnetic waves, okay, then you do. And a further tussling over whether the waves themselves are material in some sense, you would have to precisely define what you mean. I don't see any point in getting that precise about it. I don't see you gain anything at that point.
Do you not feel at that point then we're almost then going towards the physics understanding of, well, taking into account, we were just discussing philosophy versus how scientific inquiry is different. Do you not feel if we do not do that, then we almost make the mistake of what the physicists are currently doing and just going with the flow and shutting up and calculating in a sense?
No, not at all. I mean, let me give an even more dramatic example. Every approach to quantum mechanics that seems to have any chance of being correct, postulates a thing that is represented by a mathematical object called a wave function. Now, there was a big debate for a long time whether there is any such thing, whether wave functions, these mathematical things, represent any physical feature of an individual system. Okay? So that's a very well-defined question. I have a single physical system, ultimately the entire universe. That's really going to be the one there is. I ascribe to it a wave function, which I use for calculating. Okay, does that wave function represent a physical feature of that individual system? Now, there are different answers you could take to that. Einstein didn't think so. Einstein thought, no, really, wave functions are merely statistical devices. They represent statistical averages of ensembles of systems, okay? These people nowadays who go under the name cubism say, no, wave functions don't represent anything about the system. They represent your knowledge. And so, you know, people like Chris Fuchs will say psi ought to be not put on the system, but pasted to your forehead because it represents your information, right? So that's not a feature of the physical system. It's a feature of you. And then there were people who thought all along, for kind of obvious reasons, no, there really is a physical feature of the individual system, which is being represented one way or another by this thing, which is often called the psi ontological position. So you can have a debate about that. Now, I think there's a certain theorem, the PBR theorem. I think there were lots of phenomena which you couldn't understand in this. So the first one we call psi statistical, right? Psi represents not an individual thing, but a statistical thing. And the other psi, I don't know, subjective, I don't know, there's a word for it anyway. And then psi ontological. And I think there's a theorem that essentially shows you've got to go that way, that the wave function does represent a physical feature of individual systems, ultimately of the universe. Now, we come to your question. Is it material? Not by any sense of material that Newton would have recognized, right? Not by any sense of material that think, who cares, right? If you accept that it's real, that's the big decision point. The difference between this and shut up and calculate is you ask, is it real? And then you say, I don't care, shut up and calculate, right? I don't care about deciding between psi ontological and psi statistical and psi epistemic. I guess that's the third one, right? I don't even care because you've given me this mathematical gadget. I know how to calculate with it. Shut up and calculate. So that's the thing that kills you, right? That's very different than saying, okay, once you're clear, my theory postulates this thing, then adding qualifiers like material, immaterial, non-material, some other super material, I don't know. Yeah, there I don't see that it makes a lot of difference. I don't think our concept, let me put it this way, I don't think our concept of materiality was born in a setting where we had to make decisions like that. And so it's just kind of neutral about it. I mean, this happens all the time. Take the obvious concept mother. So we all grow up, we say, I know what a mother is. We can certainly point to certain people and say, she's a mother. And then there are more unusual situations where the markers we use for that come apart. So the easiest one is just adoption, right? And then you say, oh, now I need to make a distinction, biological mother, adoptive mother. If someone says, who's the real mother? You might say, oh, stop. I mean, real is not, I mean, it's offensive in some cases. Or then you go even further. You say, oh, I'm going to take this fertilized egg and I'm going to put it in this other person. Who's she? Oh, she's the surrogate mother. Well, wait, I'm actually going to take the cytoplasm from this egg and plug in the nucleus from this other egg. Now, who's the, and you say, look, as long as I've described to you what's happening, the word mother just didn't arise in English or in any language in a circumstance where you had to make these finer distinctions. And so there's just no fact about how it goes. The fact is, You now have to think about situations you hadn't thought about before and just be clear when you're talking about them. But there's no point in having a fight over it, right? What does, quote, mother really mean? It doesn't really mean any of those particular things because it didn't have to, right? We didn't have to make up our mind what we meant.
Yes.
Right?
I feel like this whole relative aspect of it all is quite concerning in the sense that when you think about us as biological beings that evolved on this planet with certain heuristic adaptations or whatever predispositions we were confined to within this atmospheric filter, do you feel that because of that we are obviously limited to the access of reality we can attain? There's always going to be some sort of a limitation to what we can perceive and how we define these concepts in the first place. What sort of philosophical implications does that have for us in our understanding of what matter will eventually be?
Yeah, I don't think that's a philosophical question in the sense of one that could be answered with using philosophical tools. There is a question which you're bringing up and other people have brought up, and it's often under the kind of rubric of saying, look, we're animals that are descendants of animals that had to survive in the savannah. And because of that, the selection pressures were for a kind of intelligence that would help you survive in the savannah. And that kind of intelligence, why would you think it's up to the task of understanding subatomic physics or cosmology or whatever? Maybe, as they say, trying to understand the universe is like trying to teach a German shepherd calculus, right? They're just not going to get it. And there's nothing one can respond to that possibility except say, yeah, that's possible. But then you have to say, all right, now it's empirical inquiry. Are there markers that somehow it's just our intelligence or our way of thinking about the world or whatever are not up to this task? And there we have very, very compelling evidence that we're really up to going far beyond the savannah, right? I mean, whatever you think of it, physics works really well, right? The standard model works really, really well for stuff that had, at subatomic scale that had nothing to do with surviving in the savannah. And structure, theories of structure formation in cosmology work really, really well for issues that didn't come up in the savannah. We know that our intelligence is up to tasks that go far, far beyond those limitations.
So that's
not a proof they go far enough, right? That's not a proof that we won't hit a wall somewhere. But the only way to find out if we hit a wall is to keep going and seeing if you hit the wall, right?
Yeah.
But to understand whether you've hit a wall of that sort, you have to be very self-aware about what you're doing and the kinds of problems you're running up against and so on. I mean, sure, maybe at some point physics will just fail and we'll never understand why it fails because we're not smart enough to understand the problem.
Yeah, I was just going to say, I mean, there's so many unknowns. How do we even know if we hit the
Right. So what do you do with an unknown? Well, you can't, because it's unknown, you can't do anything except keep going and see if you bump up against it at some point. We certainly have done extremely well, far beyond the needs of evolution, right? Human intelligence just demonstrably is not limited to what evolution needed us to be able to do to survive.
Yeah.
I mean, look, Andrew Wiles proved Fermat's last theorem, right? That's not going to help you in the savannah. It was really clever and it was hard, and he did it. So I'm an optimist, right? I mean, why not be an optimist? If you're a pessimist, then just pack up your bags and go away. What can you say? I can't prove you're wrong. But that you shouldn't be in this business.
I know. I was just about to ask you. I mean, what are your own intuitions about it? But I mean, you've clearly answered that.
Yeah.
Do you think that this limit or this wall that we might hit would come sooner than we think, or do you think it's still going to progress for quite some time?
I think this is the unknown of the unknown. I mean, I can't. There's no point in speculating about the nature of something about which you have no information, whether it even exists.
Yeah.
As I say, if the only way to find out if there's a wall is to keep going until you seem to hit it. And we're not there yet, right? We have problems in physics, but none of them look in principle intractable, and there are proposals for dealing with them. Maybe none of the proposals on offer are correct, but it just doesn't look like. I mean, this is very different. Let me maybe make a contrast here. Here's something that I don't think we do understand, and I don't think we ever will understand: consciousness. Right? Why should some physical systems have interior lives? Why should some physical goings on in brains be associated with pain, with the felt unpleasant feeling of pain? How do I get from the physics description of that to the subjective description? I don't think we have a clue. I don't think, unlike the case where, say, putting together quantum mechanics and relativity, general relativity, there are lots of suggestions on offer that could work. I don't think anybody's made any suggestion. I wouldn't know what a suggestion would even look like that could make sense of that. And there, I don't work on it, right? I mean, I wrote one paper, which was a negative paper, saying you're not going to understand this using, the theory of computation. Sorry. But I don't work on it because I don't see any prospect for it. So I work on stuff where there certainly are prospects. So it's not like I necessarily think there can't be cognitive limits. And maybe, and I'm very inclined to think the mind-body problem is one. And then I do the normal thing in such a case. I mean, I could spend all of my days just trying to shoot down proposals that people come up with, which God knows they have them, and panpsychism and this and that. But to me, that's not very interesting, right? I'd rather spend my time in a more what I consider to be productive way.
Well, then what did you say about, so there's a difficulty to try and define these terms. I mean, consciousness, the mind-body problem, it's a very difficult concept. The hard problem of consciousness, as David Chalmers put it. What about those who take consciousness to be fundamental in terms of what we were just discussing as reality? So sort of an idealist perspective. Do you think they're also going down the wrong path?
Well, officially idealism in the history of Western philosophy is associated with a very specific position, which says all that ultimately exists are minds and their contents. I think that's crazy. I think that's insane. I think there was a universe after the Big Bang that didn't contain any minds or any contents, and it was there. And it was because it was there that eventually, for reasons I don't understand, eventually minds with their contents evolved out of it. So that strikes me as just. I mean, I would have to give up on physics to believe that, and I think physics is on a much better epistemic standing than a proposal like that.
Yes.
I mean, look at what happened to the idealists like Berkeley. It was literally Deus ex machina, right? When you tried to, or Leibniz and pre-established harmony and monadology. I mean, literally they had to appeal to God to be doing all this stuff with the minds, because they didn't have a physical world. They were trying to get the physical world out of the minds rather than the minds out of the physical world. And, appeal to God, to me, this is not interesting. This is now just giving up.
Yes. I mean, you mentioned something earlier with regards to with quantum mechanics and when trying to discuss physics and the mind. It often leads us to quantum mechanics and trying to think about certain things like the observer effect. What I've noticed quite often is, because this podcast focuses on the nature of reality, consciousness, the mind-body problem, etc., you get a lot of experts from different fields who are in a specific field and view all these theories very differently. So let's say you get someone who's a psychiatrist watching this episode, and us talking about physics, quantum physics, etc., there's often these misunderstandings regarding certain concepts. So the one big one I've noticed, and a lot of people in the comment sections tend to do this, is talking about the observer effect. A lot of people tend to think that you need some sort of a conscious human observer to discuss this concept. I want to know from your perspective, how does this observer effect get misinterpreted by the layman or by anyone who's a specialist in another field that specifically talks about minds? From your
I mean, let me at least talk about one thing, an example of what some people mean by an observer effect, the so-called Zeno effect in quantum mechanics. And the Zeno effect it has to do with, suppose I have a system and I know how it would evolve if left on its own. I know it's free evolution, but I don't allow it to evolve on its own. I interact with it, or I set up some other system that's going to be interacting with it and maybe doing something that we call normally doing a measurement.
Mm-hmm.
Will that, first question, will that have any influence on my system? Well, sure it will, right? I mean, it would be the weirdest thing in the world if you could do something you called a measurement and not physically interact with the thing. I mean, you can kind of do that in a way you wouldn't expect in quantum mechanics. This is what surprises people. People always think, oh, quantum mechanics makes, in classical mechanics, observations just can have no effect at all. And in quantum mechanics, they must have. Actually, it's just the other way around. So there's this Elitzer-Weidman-Baum problem that illustrates how you can make what are called interaction-free measurements in quantum mechanics that you couldn't do in classical mechanics. But we can get into that if you want to later.
Okay.
Let's leave that aside. Just intuitively, you'd think, wait, I'm interacting this thing with another system. Of course it's going to affect it.
Mm.
How is it going to affect it? Well, that depends upon a close physical analysis of that interaction. And sometimes the effect will be quite dramatic. In the so-called Zeno effect, you're, as it were, continuously monitoring a system for something. And because you're continuously monitoring it, you freeze it. Whereas if you weren't monitoring it, it would evolve in a certain way. You could sort of think of it as an arrow that's rotating, and the free evolution is just to do this. But as you keep monitoring it, you kind of keep kicking it back to its original position. So it freezes, right? This is why it's called the Zeno effect, right? This evolution goes away. Is that comprehensible? Sure. You understand that by just understanding the nature of this interaction. Now, does that have anything to do with consciousness? Not a thing. Because what you're doing is you're modeling your original system as a physical system, you're monitoring your monitoring system as a physical system, and you're modeling the interaction, the physical interaction between them. That doesn't require any of them be conscious. It doesn't require that this thing be a measurement. It doesn't require that it be an observation. It's just an interaction, right? Just a physical interaction, which if you have the physics that's up to it, the physics can account for what that interaction and the effects that it will have. Now, people often say, as I said, oh, but in classical physics, you can measure things and not affect them at all. And I've never gotten an answer to what classical physics they're talking about. I don't even know what they mean. Why think that in Newtonian mechanics, you can measure something and not have an effect on the system? I mean, you measure something, you interact with it, there are forces, there's the action and reaction. Of course, if you do something as simple, a simple example everybody will understand. I have a glass of water in front of me. I want to know what temperature it is. Okay, so I take a thermometer and I stick it in and I wait for the thermometer to equilibrate, right? The mercury goes up and eventually it stops. And that gives me a number. Good. Is that number the temperature of the water when I put the thermometer in? No, it isn't. Why not? Because there was an interaction between the thermometer and the water. Typically, the thermometer is colder than the water, and therefore the temperature it arrives at is going to be a bit lower than the temperature the water was. Now, of course, if I'm very clever, I can, because the thermometer is self-measuring, I can know what its original temperature was, and then I can account for that and say, gosh, before I put the thermometer in, this is what the temperature was. I can be really clever. But to do the experiment, of course, there's an interaction. Of course, it affects the object. And, classically, of course it does. As I say, it's just the opposite. Quantum mechanically, I can do really clever things that can at least have a chance of giving me, you have to be careful here. They have a chance of giving me information about a system without apparently interacting with it at all or changing its physical structure at all, which you wouldn't expect to be possible, but is allowable in quantum mechanics in very cleverly designed situations.
Another thing I keep saying is this temporal aspect of it all. If you take into account, if you're looking at a particle, let's say via a telescope that has microscopic features, and you're able to see on a quantum scale or measure something that's far away, are you technically defined as some sort of a time traveling entity? This is something I often say.
Yeah, I mean, I would say anyone who says yes to that doesn't understand what a time traveling entity is. I mean, this is the most trivial thing in the world. Of course, you look up in the sky, it takes, what you're reacting to is the light that's hitting your retina.
Mhm.
And that light was traveling through space for quite a while. And the things you're seeing are not happening now. Everybody understands that kind of trivially. It's very easy. There's a very funny, I mean, I just have to mention this because it's very humorous. There's a very funny passage in a book by Glenn O'Connor. And he has this character who's kind of a crackpot physicist. And he says, oh, well, you see, if I look at myself in a mirror, I'm not seeing myself as I am now. I'm seeing as I was a little bit before because of the time it took the light to get from my face to the mirror, bounce off the mirror and get into my eye. He's talking to somebody. He says, yeah, of course, but that's, a trivial amount of time. Why do you care? And he said, well, you see, I set up this situation with a pair of mirrors. So I have this infinite corridor, right? We all know the spec. And then I got a telescope and I started looking and I got younger and younger and younger. And I followed this all the way back to where I was a beardless youth. And I would have continued it on into utero, but the curvature of the earth got in the way. And you would say, no, this is really, you're not understanding what's going on here.
I think I mean that is quite a funny story. What I was specifically trying to ask, sorry, I don't think I phrased it correctly, but what about that measurement component I'm talking about? So where you do affect the particle, at that point, are you considered to be someone who's not only traveled in time technically, but also affected a particle by measuring it in a sense? Is that,
again? I mean, I don't know who would say something like this. A photon. I mean, just leave the details aside. A photon comes into my eye. It sets off something in my retina. Of course, that interaction with my retina really massively has affected the photon. In fact, it's gotten absorbed. It doesn't even exist anymore. That's happening now. That's not happening a long time ago. Even if the photon is carrying information about things that happened a long time ago, it going into my eye is not anything happening in the past. It going into my eye and being processed by my eye is something that's happening now. So, if there is anybody, and I'm not making this accusation because I haven't heard anybody say anything quite that silly, but this is silly. I mean, this does not take a PhD in physics, right, to understand that line of reasoning really doesn't hold up to scrutiny.
The reason why I'm bringing this up is because I think that with the observer effect in mind, and I mean those measurements, how they affect reality and vice versa, I think that once quantum mechanics grew out of the field of physics, it made it a lot easier for people to make sort of wacky theories regarding reality. And my biggest concern with that is that it's almost so relativist that you can't really now have discussions in a reasonable manner because so many theories can be so outrageous to a point where you can't really disprove it.
Yeah, well, I mean, some of them, I mean, I think you could just, I think this idea but anyway, I mean, how did we get into this situation? Again, this is this peculiarity of quantum mechanics that although it didn't have to be, when quantum mechanics was first kind of formalized in the Copenhagen spirit, and especially by von Neumann, in literally writing down the fundamental postulates of the theory, the term measurement came. And this was already a big mistake. And this is John Bell's paper against, quote, measurement is the locus classicus for saying why this is a mistake. And it's basically because, what do you mean by a measurement? I mean, is every interaction a measurement? If not, what does it take? Now, you don't, in normal everyday life or in normal physics, in classical physics, you never had to answer a question like that because whether you categorized an interaction as a measurement or not was not important for applying the physics. The physics was just Newton's equations and some force laws. And you can apply that without deciding whether this thing bumping into that thing constitutes a measurement. And Einstein recognized this, right? Einstein famously said, It's the theory that tells you what you can observe, which means you don't have to first decide what you can observe and then build the theory. It's the other way around. You build the theory and use the theory to analyze interactions, and then you can decide which interactions are measurement-like in the sense of providing you information about an object. But what Bell complained about, he said the word measurement just shouldn't appear in the foundational statement of any fundamental theory. And I think he's absolutely right. If you do that, if you make that mistake, then of course it becomes a first order question, what constitutes a measurement? And then you got all this stuff. Oh, you have to have an observer. The observer has to be conscious. That leads you into Wigner, and that kind of leads you toward the direction of idealism and blah, blah, blah. But that was just crazy. I mean, nobody ever should have taken that. And Einstein didn't take it seriously. I mean, that was his, can a mouse do this? Right? Is this amazing thing that you're having to postulate? Can it observe? Is it an observer? Is an amoeba an observer? I mean, does a piece of iron observe the amount of water in the atmosphere around it by rusting? I mean, rusting is a physical interaction, and it provides information. There's no question, by looking at the amount of rust on a piece of iron, you can gain information about how much water there was in the atmosphere. Is that a measurement? Is that an observation? Is the piece of iron an observer? Is it a measuring device? I mean, these are just silly questions.
It does sort of blur the line when people, especially if somebody doesn't come into the conversation with a background in physics. I mean, it becomes very easy to assume that then consciousness becomes this interacting phenomenon that, that directly.
Yeah, and this takes you back. I mean, look, this is the kind of thing, I'll just mention this from the history of philosophy.
Yeah.
Descartes took very seriously some things we were talking about here. He took very seriously that there's a strict distinction between the material and the immaterial. And among the immaterial things were souls that humans had. And weirdly enough, he didn't think dogs have, which I thought, I mean, either he was just a very nasty person or he didn't need a dog. Anyway, and he was a real interactionist, right? That somehow, and this was again, God, if you ask how, well, God decides. Certain events in your body affect your soul, and certain decisions in your soul can affect your body. And then he was struck with this question. It's a good question from his point of view, but where does that happen? And by God, he came in the middle of the pineal gland. I mean, if you had a microscope and you could go and look inside the head of a living human being, you would find the normal laws of physics break down at a certain place where someone's mind has jumped in and decided, no, you particles go this way rather than that way because I've just decided to raise my hand. Okay, that's a theory. It's kind of lunatic, right? I mean, nobody nowadays would take a theory like that seriously. I mean, it's just crazy, isn't it?
Yeah. It's kind of like with.
So, I mean, you can talk about that stuff, but then have the courage to really, really seriously work out the consequences. And I think when you do, you'll find the consequences are so lunatic that you're going to go look for some other way to deal with these problems.
It's similar to, I think, the approach that Francis Crick and Christoph Koch took with physics, trying to apply it to consciousness, and then taking the claustrum as that basic pineal gland, in a sense. Do you think that approach is just?
I mean, and look, a bit of this comes up in this microtubule stuff that's associated with Roger Penrose and so on.
What are your thoughts on that?
I find that I first of all, like everybody else who knows a little physics but not a lot of neurobiology, I can't believe that microtubules in the physical circumstance they're sitting in do much in the way of keeping coherent quantum superpositions going, because there's just too much noise that it's not going to work. Even if it did, the idea that somehow just because you've got really fundamental quantum effects, that has anything to do with consciousness. I mean, you have fundamental quantum effects in the two-slit interference. If you're going to tell me that tells me that electrons are conscious, again, I'm going to say you've gone way off the rails there, right? I mean, if you believe an individual electron is conscious, I think you're so far beyond any connection to what's plausible that what you're doing can't make any contact to anything I would take seriously. course electrons aren't conscious. Single electron. I mean, you got to be kidding me. The little we know about consciousness is it has something to do with very complex neural structure.
Mm. With regards to your intuition regarding consciousness, I know you said that you're able to talk about the flaws in other theories, for example, computing consciousness, computational models. Talk to me about that and why you believe it's so incorrect.
Oh, well, that's just, I mean, I would say, I mean, theorem is a hard thing to throw around here, but as near a theorem as you're going to get in the area. So people ask this question. It's a good question. What distinguishes conscious from unconscious systems? Mm-hmm. And a proposal had to do with what kind of computation the system is doing, that there is going to be a computational definition. The systems doing this kind of computation on this kind of data are conscious, and other ones aren't, something like that. So there's a proposal. It says, I'm going to try to get at the essence of consciousness via the theory of computation. Well, what do you mean the theory of computation? Well, what you mean, or what people, was Turing's theory of computation. This is what we had. Turing machines, Turing, and it's true, once you have a physical item, and you identify it or categorize it as a Turing machine, which means you have to do a bunch of stuff. You have to say, okay, here are its internal states, here's the memory. Now, by analysis, this is how how the internal states shift on the memory and what they do to the memory. And there's all this kind of fancy, but very precise mathematical definition of what a Turing machine is, what its program is, blah, blah, blah. Okay. Now, if you look at what it takes for a physical item to count as a Turing machine, you find the following curiosity, which is that almost all of what determines what program a Turing machine is running are claims not about what it actually does, but about what it would do. They're counterfactual claims, right? So in fact, there was a 1 in this register in the memory, and the thing went into this state. But in order to be running this Turing program, it has to be the case that had it been a 0 instead of a 1, it would have gone into that other state, right? So this is just the way a Turing program is defined. Then it turns out, and this is what I show, this is an old paper called Computation and Consciousness, the first paper I ever published, as a matter of fact. It turns out that physically it's possible to implement a Turing program, in a way that, as it were, all of there's what it actually does, and then there's all these counterfactuals, and the counterfactual supporting part of the machine can all get kind of shunted over to one side, where on this actual run, it doesn't do anything. I mean, it's just literally physically completely static. It's important that it's there because its presence there, this piece's presence there, is what makes these counterfactuals true about what would have happened if the tape had been different, right? But it's not actually doing anything in this particular run.
I see.
And then the claim is, look, the claim I find unescapable is that the conscious state supervenes on physical activity, on the activity that's going on. But if that's true, then the presence or absence of this other piece that's not physically active is irrelevant. So I can just lop it off. But if I lop it off, then it's no longer running the same Turing program. In fact, it's not running any interesting Turing program at all. So, if you just believe that your present conscious state is determined by the present activity in your brain, then it seems to me this particular way of understanding a computational theory of consciousness cannot be correct. Yes. This is the burden of that argument. I stand by it to this day. I whenever I go back and review that argument, I think, yeah, that's right.
Yeah. Have you heard of Stephen Grossberg's adaptive resonance theory?
No, I'm afraid.
It's very intriguing. He works at Boston University, and many years ago, I mean, he made this theory, 1950s, I'm not even sure, but he talks about us often mistaking things, conscious activity for things. And that's the biggest problem we make, is that it's all dynamic systems. So you use dynamics within mathematics to sort of define this. And our biggest mistake is actually reducing these activities into things, because you can't really think of it that way. Do you think that you're...
Yeah, I mean, if I understand the suggestion, that seems right. I mean, consciousness, I mean, Buckminster Fuller had a book or a poem or something. The title was "I Seem to Be a Verb." And, his point was just that. I use a lot of nounish kind of language to talk about myself, but what I really am is an activity, right? I'm an ongoing process.
Exactly.
That seems right to me.
Yes,
I certainly think consciousness is a process, sure.
Yes,
I don't think a static thing that's unchanging, physically unchanging through time can be conscious. How could it be? That's so sure. And insofar as people are making that mistake of calling processes by words that suggest they're not processes but something else, that could be misleading. I don't think noticing that mistake is then going to lead me to what I would consider to be an acceptable theory of consciousness, because I think the problems confronting that are just much deeper than that. But that would lead people in the wrong direction. Sure.
Do you think
is a pain a thing? Well, a pain is an event or an activity or a process or something. It has to go on through time, and so to think of it as a thing on the model of a rock, yeah, you're going to be awfully confused if you think they're like that. No, they're not like that.
Do you think if we're able to replicate this activity, we can sort of create artificial unconsciousness?
Of course. I mean, again, to me, this is trivial. Yeah. There's nothing that would stand in the way of us artificially creating a brain like mine or like yours. And because it's like mine or like yours, and because I know I'm conscious, and I sure believe you're conscious, I think such an artificially created brain, but I mean a brain with neurons and axons and stuff like that. Nothing is preventing us to artificially create that. Now, the problem is when people say, oh, but by an artificial brain, I mean, a big computer thing with a bunch of tape decks and this and that. I don't know whether a thing made of tape decks can be conscious, right? I don't know whether something made of silicon can be conscious. Why? Because the only thing I know for absolute sure is conscious is me, and then any normal, right? Unless you're crazy, you think other human beings and dog. Again, if you've ever interacted with a dog and you don't think it's conscious, I don't know what's wrong with you. But there are lots of biosimilarities between dog brains and human brains, right? You get down to things like lobsters, and I don't know.
Yeah.
Right. I just don't know. And it upsets me that I don't know, for reasons that, you don't want to torture lobsters. There's a hypothesis, which is that when you throw a lobster in a pot of boiling water, it makes a high-pitched sound and waves around, and you think, oh my God, it's like I dipped my hand in a pot of boiling water. That's really painful. I hope I'm not doing that. And then people say, no, these are just autonomic reactions. They're going on without any accompanying sense of pain. Maybe, how do you tell? But that's as far as it goes. And certainly if somebody makes a computer and their design has been to make it so that it behaves outwardly like a person, but inwardly it looks nothing like a brain and doesn't work at all in the same way, I'm not going to be fooled by thinking the fact that it outwardly acts like a person to thinking that it's conscious. You made it to act that way. I mean, these large language, chat bots, they're not conscious. I know they're not conscious because I know how they work. I had somebody, somebody came to our department and explained how they work. They're just statistical analyzers doing, a bunch of analysis on texts. And those texts were created by actual conscious, comprehending human beings. And because they were created by comprehending human beings, if you do the right kind of statistical analysis, you can produce behavior that sounds like it's coming from a conscious human being, but not because the thing is conscious. It isn't. I know for sure chatbot's not conscious.
Yes.
But sure, it can act like it. It could fool me into, I could be fooled if I didn't know I was interacting with it. So what?
And the truth is, we can't really even tell. I mean, if you and I are, so that whole philosophical zombie argument also doesn't really apply technically to when we talk about each other, because there's no real way for me to know if you.
It doesn't, but if you go that far, I mean, if somebody says, look, I know I'm conscious, but if I were to say right now, I know I'm conscious because I'm here inside, right? And I don't know you're conscious. I think, oh, come on. I mean, that's not serious. Of course, you know other people are conscious. I mean, what kind of a lunatic view is it that you're the only conscious being in the universe?
But
I mean,
solipsistic, eh?
I can't, as it were, logically refute it. But come on. I mean, this is just a joke. Don't waste our time with this stuff. Yes, people are conscious. Yes, dogs are conscious. Lobsters, I'm not so sure.
Yeah, it's all those alien-like species. So like octopi, octopuses.
Octopi. I don't know. We just actually found my wife, an octopus came and grabbed her ankle. So we saw an octopus, and man, I mean, they're really interesting animals, and we know that they're in a way have a kind of control and intelligence. But to use Nagel's phrase, what is it like to be an octopus? I have no idea. And I don't know how I would, I can analyze octopus neural systems till the cows come home, and I'm not quite sure what I'm going to find there that would answer that question, right? What does it feel like to be an octopus? Or, I can analyze the neural pathways in a lobster. What am I going to look for to tell whether it feels pain? I don't know what to look for. That's because of the hard problem, as far as I'm concerned. But things like dogs, they're very similar in all sorts of ways. I may not know which of those ways are relevant and which are irrelevant, but there are enough similarities, and then enough similarity in the behavior and so on to say, well, of course they're conscious.
Yeah, no, I completely agree with you in that regard. Tell me, Tim, with the work you're doing, and when you think about metaphysics of physics and the studying of ontology and trying to understand this universe, what part of this all excites you the most at the moment in your life?
I mean, right now, what I'm spending my time doing, or should be spending my time doing, because I'm too lazy, is thinking about, so the physics. There are three main pillars of physics. We used to say there were two, and we said, well, there's theory of relativity, which is really a theory of space-time structure. And there's quantum theory, which is, as it were, a theory of the stuff in space-time, which includes matter. We used to say those were the two great pillars, and we don't quite know how to put them together, right? How to join them, which is right. And then we started to say, which is an interesting thing to say, well, there's really kind of a third pillar. It's of a different character. It's statistical physics. It's thermodynamics. It's explanations in physics that necessarily appeal to statistical phenomena of large ensembles and things like that. And I think it's right that there are explanations and sources of understanding there that you need, and you won't get just by looking barely at space-time theory and barely at, right? But the thing about the statistical part, the thermodynamics part, is it doesn't make any new ontological postulates. It doesn't say, oh, here's something that the high energy physicists missed. No, it says, here's a way of thinking about what the high energy physicists have found, and producing explanations out of it. So let's shunt that aside. That's not that part of it isn't really worried about ontology in what there is. So what are we left with? We're left with space-time, which is kind of the arena, as we say, in which things happen. And then there's the stuff that's happening in space-time, right? That's kind of part of theory. At the moment, what I've been working on for some time is a proposal on the space-time part. That's what if space-time has a discrete structure, which is quite different than Euclidean geometry or special relativity or general relativity. All of these are continuum theories where you can always take any distance and have it and have it and have it and have it, right? There's no end to that you don't ever get down to a fundamental atomic unit of distance, as it were, or area, and it's been known since antiquity, since maybe it bottoms out somewhere. Maybe ultimately space and time really are discrete, have a discrete structure. And I actually think that hasn't been considered enough or studied enough. There, you can say that, but then there are a billion ways to try and implement such an idea.
Mm.
And I'm working one of the billion ways out.
do you think this quest?
That's what I've been working.
Do you think this quest that you guys are on to sort of fuse these two fields together, or to get them together, to get a theory of everything? How much work has been done on it from your side that you think is going to sort of bridge this gap?
I don't know. Everybody talks about a quantum theory of gravity, which would be something that brings together, because gravity is what is explained. The best theory we have for gravitational effects is general relativity.
Mm-hmm.
And for matter is, of course, the standard model of quantum theory. And those two theories don't play together very well mathematically. So then there's a question, well, what do I need to do? Do I need to quantize gravity? People talk about that to kind of just bring the gravitational part over into the standard model part. There's something curious about that, which is that there's a kind of deep intellectual insight about the nature of gravity suggested by general relativity. And as far as I can tell, if you try to do that, you throw that away. You say, no, Einstein was wrong about that. That insight was that what we call gravitational effects that Newton ascribed to forces aren't ascribed to forces at all. They're ascribed to the curvature of space-time. That's a really interesting idea. It works very well. I personally would be very sad that turned out not to be correct. The other idea is to say, no, it's really gravity just isn't like electromagnetism. Really, the insight of general relativity is correct. Gravity is a different deal. Don't try to assimilate it to these other, to electromagnetism and weak and strong nuclear forces and so on. It has to do with fundamental space-time structure. And what you need to do is think about what fundamental space-time structure might be, and then how you formulate the quantum mechanical part in terms of that. That's the way I'm going.
Yeah.
Maybe it's right, maybe it's wrong. You only find out, by poking along. I mean, you can only find out for one particular way of trying to do that. And I'm kind of poking along in a certain way to see what happens.
With reading your books and your papers, I mean, it's clear that Bell really influenced you. How did that start for you? What was so brilliant about the work that really got you gripped and then continued with it for so many years?
Yeah, I mean, look, the thing that first got me into this wasn't reading Bell. It was reading Bernard Despegnat's Scientific American article of 1979 on Bell's theorem.
Okay.
I mean, you're just a little sprout. You wouldn't remember this. Many of us in this field who were around then do remember. There's a big dung beetle on the cover. I mean, you remember that issue of Scientific American. Now, when I go back and look at that article by Despegnat, now I would raise a certain number of objections to it. I don't think what he says there is quite right. But there was enough detail to understand what the theorem was.
What did he say? What did he say? And what did you agree with? What did he say, and what don't you agree with it?
Well, he ends up saying, well, there are these three assumptions of Bell's theorem, and one of the assumptions is, I don't know, induction or something. I mean, some very general methodological thing that, you want to say, look, one of your options is not to give up on induction. If you say, oh, I'm going to get around Bell's theorem by denying induction, I mean, it's like, what are you talking about? You can't do that. And so there were kind of suggestions that there were ways around the theorem, which I think they're not ways you can take and maintain physical science at all. I haven't read it that recently that I can tell you chapter and verse, but he gave the mathematics and he gave the example with the singlet state clearly enough. I'll tell the story. I was a senior in college, and I lived with a couple other people in a room, and I had taken we all had a bedroom. I had taken the living room. That was my room. And we had windows that looked out onto the sidewalk. And they looked in and they saw me. I was holding this thing in my hand, pacing. right? I was just had this look on my face like this, holding this magazine, walking in circles around the coffee table. And they said, "What's wrong?" And I was reading that article, and you kind of, it was enough there to say, no, this is really weird. This is an amazing, amazing discovery. I understand the people who thought at the time, when they go into the lab and check, is this inequality violated at space-like separation? The answer will be no. We're just going to find quantum mechanical predictions break down because it's so weird, right? To give up on locality.
Yes.
It is the last thing in the world you would expect. Because why? Because local physics, I mean, Maxwellian electrodynamics is local physics, and Newtonian gravity, if you implement it in the normal way, is local physics. I mean, local physics did really well, and Einstein had worries about what would happen if it wasn't local. They're good words. You don't want to give up on locality, but you got a theorem, and then you have some experiments. And I'm sorry, that's just, you got to give up on it. And then you really were. So, it was the result that first got me interested. Now, then when you go and read Bell, he's such a genius. I mean, he's such an unbelievable, off the scale, beautiful thinker, beautiful writer, clear. His only flaw, as I say, the only flaw Bell has as a writer is that he's too concise. He'll say exactly the right thing in exactly the right words in a sentence, and then he makes the mistake of thinking that readers are careful enough to digest that, and then he can rely on your having understood that for everything that comes after. And the problem is, as if you are around humanity much, you realize you can say it right and you can say it clearly, but people are just too sloppy when they read. And as I say, he was a surgeon with words. My technique, as I say, I take a 2x4 and whack you over the head about 100 times with the same thing, saying, look, because I know people, it's hard to get through. But if you appreciate him, if you read him carefully, every now and then, even Homer nods. Every now and then, Bell said something that I wish he hadn't said. But it's very, very rare. And the amount of understanding and insight and clarity about not just quantum physics, but about science, about physics, about everything. I mean, he was a natural, as we would say, a natural-born philosopher, the way Einstein was. I mean, Einstein knew that he liked philosophy and spent time reading philosophy. I don't know if Bell did or not, quite honestly. But he would have been great philosopher in a philosophy department because he was a clear thinker.
Aside from his physics and from the work he's done, what sort of deep philosophical insights do you feel like he's given you in life in general?
Well, so let me just take something that is relevant to what we were talking about before. People somehow think, gosh, in quantum theory, the observer gets injected back in, right? The observer was kind of kicked out by Newton and Maxwell and Boltzmann, but gee, the observer creeps back into physics with quantum theory. And this is one of the things Bell says, no, that's not right. Now, the question is, all right, why might you think that? Here's one thing to think. You say, well, ultimately, the data that we have are conscious experiences, right? That's the evidence. And so to use that as data for physical theory, you somehow have to connect consciousness to physics. But that requires solving the hard problem. I mean, you see how you go in that direction.
Yes.
And Bell said, no, that's not right at all. Because we don't, first of all, we don't have a clue how to do that. And Newton didn't have a clue how to do that, and so on. So how does it really work? It works this way. What we take ourselves to have reliable access to is the macroscopic positions and motions of macroscopic objects, like a needle on an ammeter. We can just look and see, did it go this way or that way? We can reliably tell, did it behave this way or that way? Now, does that involve consciousness? Sure, it does. Do we know how that works? No, we don't. But you better take for granted that that's a reliable piece of information. Otherwise, physics is dead in the water. If you can't tell whether a needle went to the right or the left, then you have nothing to test your physics against. So what Bell said, and this is in a theory he called the theory of paper he called the theory of local beables. And the interesting thing about that is that the needle is a local thing, right? The needle, unlike the wave function, the quantum state, the needle occupies a certain position in space, and that position changes. It goes this way or that way. This is the local behavior of local objects. That's what our everyday experience informs us of. And we think quite reliably. And that is the data against which we can then test a theory of physics. If the theory of physics has in it what he calls some local beables, if it postulates some local stuff that this needle is made out of, then that theory can predict, oh, it'll do this or it'll do that, or 75% of the time it'll do this and 25% of the time it'll do that, or whatever. And then we can test the theory. Now, none of that requires talking about consciousness or whatever. It just talks about needles and what they do. And of course, we take for granted that we can see what, I say, when Galileo describes this experiment that he supposedly did, dropping, a large and small ball off of, the Leaning Tower of Pisa or some tower. And he says, oh, you let go of them and they hit the ground within a finger's breadth of each other, right? They hit the ground almost together, which is against Aristotle's theory. Fine. But of course, what's he's assuming? He's assuming you can tell how close they were when they hit the ground, right? You really have reliable access to, the order and how far apart they were when they hit the ground. He doesn't go into how we know that. And you better drop them during the day, right? If you drop them in the dead of night when it's dark out, you're not going to know when they hit the ground. Okay, but there are circumstances where we all agree we have good access to that kind of information. That's the information you then use to test your physical theory. But to do that, it means you have to be able to account for things like that in your physical theory. And to do that, Bell says, you need some local beables. I think he's absolutely right. I think all of that cuts through all of the stuff about observation and measurement and consciousness, it's gone. No, that's not the way physics works. This is the way physics works. He's absolutely right about that.
Are there any other, famous philosophers, physicists you think really sort of shaped your worldview at this point, other than Bell?
Well, I've said for a long time, which is true, that if you ask about who are the greatest philosophers of physics, in the 20th century, the first half, it's Einstein. And in the second half, it's Bell, right? They weren't people who worked in philosophy departments, but who cares? They were very deep thinkers about the nature of physics and very deep thinkers about the physical theories that were around. You learn a lot by reading Einstein. You read his letters, read everything. You see how frustrated he was because he couldn't communicate with other physicists and get his point across, and it just drove him nuts. And when you read the letters, you see why it drove him nuts, because they were being almost willfully obtuse. You learn a lot by reading Schrodinger. Everybody talks about Schrodinger's cat. How many people have read that paper? It's a beautiful paper. It's a really beautiful paper, and it doesn't say what many people think it says. But history, look, my degree was in history and philosophy of science, so I'm used to going back. I'm used to reading Newton. I'm used to reading Maxwell and Boltzmann and Einstein. And these were wonderful, wonderful, wonderful clear thinkers. And I guess they shape, I would mention them before any other, philosopher, quite honestly. But I think of them as philosophers.
When you think of Einstein and Bell, Bell's theorem, and there's sort of that tension between relativity and Bell's. Do you want to elaborate on that a bit?
Sure. Einstein theory, the special theory of relativity introduced into our picture of space and time something Newton didn't have, which is a light cone structure. Probably anybody who reads any even popular books about this will see a thing that really looks like a double cone. And at the center of it is an event. Like I snap my fingers, there's the past light cone, which is all the things that could have happened in the past, such that light could have gotten from them to this, and the future light cone. And this is not something that Newton has in his picture of space and time. It's not something that Maxwell had in his picture of space and time. It turns out that it's in the special theory of relativity. Einstein didn't quite understand that early on either. It was Minkowski who had to point this out, but Einstein came around to it. And in a certain sense, what the special theory was pointing out was that Maxwellian electrodynamics, which everybody thought to be a very serious theory, in a certain way lives naturally in this relativistic space-time structure with these light cones. Mm-hmm. And what Einstein, and then, all right, that takes care of electrodynamics. The only other developed theory Einstein had to worry about was gravity at that point. There was Newtonian gravity. And so after 1905, he has electrodynamics under control. And then he spends 10 years trying to get something like theory of gravity under control in this setting. It takes him 10 years to come up with the general theory of relativity. There's this whole race with Hilbert in the last, this sprint at the end to write down the field equations. All right, it's a very interesting historical episode. But at the end of the day, what you do, as I said, is the general theory then says, look, Newton wasn't right about gravity. Newton thought gravity was a force. And it's not. What we call gravitational effects are actually due to curvature of space-time. And you need to now go from special theory of relativity, which has a flat space-time, to a theory that has space-times with variable curvature, and you need to couple the curvature to the energy content, blah, blah, blah. Okay. But all of that means, and Einstein's idea was that if an event occurs, all of the possible causes of it lie in or on its past light cone. Mm-hmm. Right? For something to affect me right now, that thing has to be in or on my past light cone. And the only things something I do now, the only effects it can have are in or on the future light cone. And so the stuff that's outside the light cones, what we call space-like separation, can neither be a cause nor an effect of this event. That's locality. That's Bell locality. That is the very proposition that Bell investigates. It's a very general proposition, an amazingly general proposition. It's not tied to quantum theory. It's not tied to any. It's just all your causes are in or on your past light cone. All your effects are in or on your future light cone. Therefore, there can be no direct causal connections. No direct causal connections between two space-like separated experiments. And what Bell shows is that very, very general proposition that Einstein absolutely believes has logical consequences, which is amazing because it's so generic, right? It's not getting into the details of the physics at all. Just if your physics is local in this well-defined sense, here's some phenomena your theory cannot predict. Here's some phenomena that your theory cannot explain. And those boundaries are given by what's called Bell's inequality, which also has other versions depending on the setting. You're working with 2 or 3 systems. Okay, but that's the idea.
What are those limits that arise immediately that come to mind?
Yeah, so they're limits about how strongly correlated the outcomes of experiments done so-called at space-like separation, that is so far apart and so near in time that light couldn't get from here to here or from here to here, right? So Alice and Bob, as we say, or Alice and Bob and Charlie are in their labs. And again, this distance can be as far as you like. They could be hundreds of billions of light years away, accordingly. And Alice and Bob, or Alice and Bob and Charlie are all going to make decisions about how they're going to set their apparatus. And we regard, this is the other piece, we regard these as free in a sense that has nothing to do with freedom of the will or anything else like that. There's an assumption called statistical independence, and it's illustrated as Bell illustrated it in a wonderful paper by using a pseudo-random number generator, like a generator that takes the digits of pi. Okay, it starts at the millionth digit of pi. And if it's even, gives you a plus, and if it's odd, gives you a minus. So you get a string of pluses and minuses that is, in the technical sense, a completely random string. And Alice, Bob, and Charlie are using this to either they each can set their apparatus in one of 2 ways. So they're using these strings to kind of set them randomly. And we regard that as giving you a random selection out of these sets of particles that are coming in. Okay. what Bell shows is that there are certain correlations among the outcomes that Alice and Bob get, or Alice and Bob and Charlie get, that cannot be predicted by any local theory. Now, this is a I'm going to give you an example that's not quite right, but without going into, I mean, I could draw the GHZ thing on the board behind me and go through it in 15 minutes, but let me just give you a kind of example that is not quite right. So warning, right? But just to get the idea across. So here's a kind of example people sometimes get. Suppose you have 3 cards sitting on the table face down. And someone says, here's an interesting thing. Whenever you can randomly pick any 2 of those cards any way you like. And whenever you do, they'll be of opposite colors. You'll get 1 red and 1 black. And you say, wait, what? How can, you know, how can that be? Because look, if they're all 3 the same color, then of course they'll have to be the same color. Otherwise, 2 have to be the same color and 1 different. But then if I happen to pick the 2, then they're not going to be of opposite colors, right? What you know is that if that were true, if whenever you just randomly pick any 2 cards and they're always a different color, you say there's something screwy going on here, right? I mean, somehow my choice must be having an influence on the color of those cards, right? There's some fancy device that's saying, oh, he's going for these 2 cards, and that can quickly change their colors, you know. But you can't just,
spooky action.
It can't be that the cards are just sitting there with their colors and you're turning them up, right? You just can't. So a local theory would be one where they have their colors all along, and the colors just remain what they are, and all you're doing is revealing them by turning them up. And you easily see here's a phenomenon that kind of local theory cannot predict, that whenever you turn up any 2 of them, they're of opposite colors.
Yes.
It's like that.
I see what you
right? Something's going on there. There's some way that you're picking these 2 cards actually has to have an effect on what color they are. And that you know, again, if they're all on this table, you could imagine a clever magician who literally can control this in real time and, you know, alter their things. But then if you put the cards 100 billion miles away, I mean, you know, now you're just trying to insulate, to say, I'm going to try and get rid of the possibility of this kind of funny business by isolating these 3 things in these different labs and so on. But even that doesn't help. Something non-local is going on. Some way, what goes on, you've got these separated labs. It has to be that what goes on in one lab, the choices that are made in one lab, the experiment that's done in one lab, has a physical effect on what happens in the other lab. That's what physicists don't want to believe. But, you know, Bell proved a theorem.
Yeah. And that non-locality, or that spooky action at a distance, is, as Einstein calls it, I mean, that's precisely what threw the world in a storm. I mean, put everybody into this.
And that's what Einstein hated about quantum theories. I say this over and over. People think, they always, you know, repeat, oh, I don't think God plays dice, as if what Einstein was worried about was the indeterminism of quantum mechanics. And he says very clearly, very, very clearly in his letters, no, that's not what I'm worried about. I'm worried about the spooky action at a distance.
Yes.
I'm worried about the idea that an experiment done over here can have an instantaneous effect arbitrarily far away. That's what worried me. And that's the precise thing Bell says, okay, if I have a theory the way you want, Einstein, where what I do here can't do that, here are some constraints on what your theory can predict. And by the way, quantum mechanics violates those. And then, by the way, which is the important thing, not what quantum mechanics predicts, the important thing is you go into the lab and check. And that's violated. So I'm sorry, Einstein. I understand why you wanted what you wanted. But nature has not been kind to you, right? God has been subtle or malicious or something, you know, I mean, you know, things aren't working out. You had, and again, I have no problem with Einstein. I think in his situation, before you have Bell's theorem, his position was perfectly reasonable. And the responses to it by Bohr and so on were incomprehensible and not helpful. He was raising serious problems in a clear way, and they didn't have good responses to it. I think it turns out he was wrong, okay, you know, but he couldn't have known that. He didn't know about Bell.
I think, I mean, talking about Einstein, and I mean, you are primarily involved in the philosophy and history of science. I just recently watched Oppenheimer. What were your thoughts on that? Have you watched it?
I haven't seen the movie. I mean, I'm in Croatia right now. I will go and see the movie
Do
when
you,
I can, but
are you, is
I
that?
mean, I did watch, because it was available here. There's this documentary, The Day After Trinity,
Oh, yes.
that's available until the end of August on Criterion Channel for free. And it was a very interesting documentary. I mean, I didn't know all of those details. But I can't comment on the movie because I haven't seen it. I've read enough to know they took a few liberties historically, especially having to do with Einstein.
Yes.
And, it kind of makes you sad when they do that.
It does, yeah. Is that the type of thing, Tim, that you'd be looking forward to watch, though?
Oh, yeah, I'm very much. I mean, just because the reviews of the movie have been very good.
Yeah.
I mean, things like the cinematography are supposed to be great. That has nothing to do with the subject matter. And it's certainly a very interesting historical episode. And quite honestly, watching the documentary, it also shakes you up because politics has not changed, and you see how powerful just politics is, right? Politics against the truth, as we have with climate change and various other things, right? People have certain political views that are usually rooted in their self-interest. I don't want to admit that smoking causes cancer. Why? Because I'm making a pile of money selling tobacco. I don't want to admit that we're in a deep climate crisis. Why? Because I'm making a pile of money selling oil or coal or whatever. I mean, obvious self-interested motivations. And then they attack the scientists who are telling you, we're in trouble here. I mean, look at what happened in COVID. It's horrible. People who spend their lives doing nothing but studying immunology and how pandemics spread so that they could help us out. And this kind of thing, there was a book called The Hot Zone that came out. It was about Ebola. It came out in the late 90s, and it scared the pants off everybody. And it said, look, there will be these emerging viruses. And eventually we're going to get them. They're going to jump to the human population. And if they have certain characteristics, they're going to kill a lot of people. Be worried. And then people, for political reasons, decide to attack the scientists. I mean, it's horrifying.
It is. It's quite scary to see how that works. Particularly when you know the story of Oppenheimer, you know that, until he decides to ask them questions about making the bomb, using the bomb, actually, that's when he becomes a communist. It immediately becomes political.
He was the guy who got the thing built.
Yeah.
And he did it, in service of of the country and of the cause that the country was united behind. Then you say, oh gosh, he's some leftist, so I'm not going to trust him. What are you talking about? Proved himself.
Yeah. Are there any other great philosophical / science movies that you think, except for, I know you love 2001.
I do.
Yeah. Anything else like Interstellar? Anything else that you find really?
People like Interstellar because they say, oh, it kind of accurately portrays the effects of general relativity. And Kip Thorne was involved or something like that. Of course it does. It doesn't really in a practical way. Those people would be dead. They're not going to go on they're just going to die, So, it's kind of, I've got my sci-fi, thing, and then I dress it up with a little bit of stuff that looks like proper physics.
I think there's even a book called Kip Thorne's Science of Interstellar.
It's a way of getting people interested, and maybe if they're interested, they'll then find out what the real story is. I'm not fond. There are two things I'm really not fond of, which I've talked about before. I'm not fond of movies that are logically incoherent, which that's just logic. And that happens in time travels, most time travel stories, right? They just don't make logical sense. And then you appreciate the ones that do, the ones where they're careful about it, like 12 Monkeys, they're careful about it. And they understand what an actual coherent time travel, as in, All You Zombies, the science fiction writers, some of them cared about it. They were very careful. Here's a coherent time travel story. I happen to believe that time travel is not physically possible, so I don't bring physics into that, but just violating logic really gets my dander up. I mean, you understand why they're doing it. Often these things are really interested in counterfactuals, right? They're interested in what. There was a bunch of movies that came out that were inspired by chaos theory.
Yes.
Run, Lola, Run, Slide, where, yeah, you tell the story. I mean, Run, Lola, Run was actually inspired by a wonderful early movie by Krzysztof Kieslowski, which is a much better movie with the same structure, called, gosh, I can't remember the name. Sorry. But again, it tells the same story 3 different ways with a tiny little difference in the beginning, a seemingly irrelevant difference in the beginning, having pinball effects, ramifications that lead to entirely different outcomes. Now, what those movies are really interested in is counterfactuals. What if this had been a little different, right? This is, for want of a nail, the horseshoe was lost, and for want of a rider, blah, blah, blah. Can these tiny effects amplify up? And in chaos, all of them do, right? Or typically they do. You certainly can find cases where they do, but then if it's chaotic, kind of any little change would lead to a very different outcome. And so that makes you think, gosh, what if this had been slightly different? But people think about this all the time. What if I hadn't, what if I decided to go to the movies that day? I never would have met this person who I am now, the rest of my life depends upon having met this person. All of that depended on what was kind of a random choice. That's an interesting reflection about life. It's not particularly about physics, it's about life. There's one, I'll just mention one movie that I kind of, it's very science fiction-y, but I like. It's The Prestige.
Oh, I love The Prestige.
I think that's a wonderful movie. It has its science fiction-y bit to it.
Yes.
But then it has stuff about personal identity and other philosophical issues, and it's just a beautiful, I find that a beautiful movie.
I mean, I think, yeah, because Christopher Nolan, when he does make films, he tries his best to incorporate the science, but obviously it's cinema. You can't really be as specific as people, as we'd want them to be in terms of logical coherence. But you mentioned something just now, but regarding time, because your work focuses on space and time as well. Talk to me about that. Why the physics behind why that's impossible, the time traveling and.
Well, I mean, the bad time travel stories like Back to the Future are impossible for obvious reasons. Namely, of course, you can't change the past because it only happens once. The past is whatever it was. Now, that doesn't mean, this is a very kind of distinction philosophers are just trained to make. It doesn't mean logically you couldn't influence the past. So if I could go back in time and do things, those things would have consequences. And some of what happened in the past would be a causal consequence of what I decide to do now, like get into the time machine. So there's not, and this is what 12 Monkeys has and so on, and All You Zombies. Yeah, there's backward influence, causal influence. But that doesn't mean you can change the past, as if the past happened the first time around this way, and then the second time around a different way, because, now Marty McFly's father is a big tough guy, and the first time around he wasn't. It doesn't make any sense. It only happened once, right? This is just a logical problem. Changing, for something to change, you have to have 2 different versions of it that both exist, and the past only happened once.
So in this case, you're not really opening up another world. So there's no multiple.
No, I mean, look, this idea in Back to the Future, when they're sitting there looking at the pictures and people are disappearing out of the picture, I mean, this is just stupid, right? I mean, this just doesn't make any sense at all, right? You can't tell any coherent story about that. It's just as if the present is going on right now. I don't know. It's just it's just loopy, right? So that kind of thing, because I'm trained. I mean, my professional training is to point out incoherences and inconsistencies. And in movies like that, they're just littered all over the place, and the whole plot depends on them. And after a while, they grate on you, right? And then when you see something where people have done it right, you really appreciate the effort they put into it.
So the whole possible worlds hypothesis, you're not really on board with it in terms of.
No, but even if I were on board, look, for A, no, I'm not. B, even if I were, sometimes people say this, they say, oh, it's okay that you go into the past and, as it were, do something that makes a different past, because now you're in a different world. But then you didn't go into your past. You went somewhere else. You're going, having an influence somewhere else. Okay, you can do that, fine. But don't think you're going back and affecting your past. You're not. You're affecting somebody else's past. I don't know.
Yeah.
And of course, we can do that. Everything I do now affects the past of all the people who are going to come next year.
Yeah. So technically, so you're not actually opening up these pockets of multiple worlds and different variations of.
Yeah, I mean, all of that, like, oh, I'm going to be, into the Spider-Verse, blah, 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 right? Again, these are everything, everywhere, all at once. Everybody loves this many world stuff.
Yeah.
Why? Are they interested because it's physics? No, they're interested, again, because it allows a visual way or narrative way to discuss different possibilities. I believe there are lots of different ways the world could have been. And I believe, yeah, there are lots of ways that were very, very similar, right? Macroscopically, exactly similar to my childhood, that because of some tiny little change somewhere and the thing amplifying up would have gone in an entirely different direction. And that's, I mean, that's the topic of Robert Frost's The Road Not Taken. You're always haunted by what could have been, and you'll never know. That's why you're haunted by it. You'll never know.
With that in mind,
that's part of the human condition. Sorry. Yeah.
Sorry for interrupting you there, Tim. With that in mind, what are your thoughts on the physical world's impact on free will? Do you think they're compatible? Do you think they're not?
Yeah, look, I'm a compatibilist about free will. I don't think that the physics of the world being deterministic derogates from the possibility of free will at all. And in fact, it's just the opposite. This is something Hume pointed out, that the world has to be pretty well deterministic, maybe not perfectly, but very reliably kind of close to deterministic, even for free will to exist. Because if people's actions are not deterministically or nearly deterministically connected to their decisions, then you can't blame them for their actions, right? It's only because we take their actions to be evidence of what they were thinking and the way they deliberated and the values that they had, that we think we can punish them for their actions. Hume says if there weren't a strong connection between your motivations and your beliefs and everything else in your actions, then you'd be as innocent as a newborn babe after having committed a murder.
Yeah.
Right. So in fact, the way we think about free will, the thing that people don't talk about, and it's because the physics level is the wrong level to talk about this. Free will, in the way we care about it, depends on deliberation. It depends on a person believing they have different possible actions they can take and thinking, okay, if I do this, then this will happen. If I do this, then this will happen or might happen. Okay. And then looking at all of those and deliberating and thinking, of these options that I have, which is best? And then doing the thing they decide is best. That's deliberate. Insofar, and that's the kind of thing you can absolutely, if someone coldly deliberates like that and makes a choice on the basis of that deliberation, then you can praise them to the skies if they did something good and put them in jail if they did something bad, right? If what they were doing was considering, robbing a bank and shooting the bank teller in the process, and they thought, yeah, I can do that. And look, this will make it more likely I get away and blah, blah, blah. Yeah, put them in jail, right? Insofar as you start to chip away at that, we all believe, and the law believes, responsibility gets chipped away too. That's why if something's done in hot blood, where you're not deliberating, you're not coolly deliberating, you're just reacting in some emotional way, that's often taken to be a reason not to punish the person as strongly as someone who does it in cold blood. That's reflected in the law. I think that's right. And then you get down to things that don't deliberate at all, right? I don't think lobsters deliberate. I don't think, rocks certainly don't deliberate, right? That's why we don't blame them for anything. You would also say a rock doesn't have free will because it doesn't have a will at all. It doesn't have a volition. That requires representing to yourself doing various things. So the issues about the nature of free will are all up there. They're at the level of psychology. They're at the level of what's going on in somebody's head. But what's going on in their head can perfectly well be governed by a deterministic physics at the level of atoms. Why not? You know.
Yeah, because I was going to say a lot of that is touching on psychological aspects of it, and you get some people like Greg Caruso, Dirk Pierboom, etc., who talk about hard incompatibilism and the fact that blameworthiness or praiseworthiness actually is a problem. I mean, we're technically putting praise and blame onto beings that technically don't have free will in this sense. So is there a physical argument for that on the atomic scale that you...
No, I mean, I just wouldn't understand why someone, if I sit here and coldly deliberate and say, you know, I'm greedy, I want some money, I'm going to go rob a bank, I'm going to shoot some people in the process because I think it's more likely for me to get away. I understand that. I understand what I'm doing is against the law. I understand that people will be killed. But gee, to me, that looks like a good deal because I'm probably going to end up wealthy, and then I go do it. Why aren't you responsible for that? What takes away your responsibility? Physics?
A big argument they use.
No, I mean, again, why would anybody think it does? What's the argument there?
They use, I think they use Thomas Nagel's paper on moral luck as a big foundational paper.
But moral luck is a different issue. It is true that often we praise people or blame them for things that were out of their control in a way that they couldn't deliberate about them. They didn't know about them. I mean, the center to blaming someone or praising them is, did they go through a process of deliberate choice? And in certain cases of moral luck, we more strongly punish one person than another, even though their deliberative process were the same, right? So, I mean, just take this example. I'm late. It's kind of late at night. I want to get home more quickly just because I'm tired. I'm coming up at a stop sign and I say, oh, what the hell? There's not much traffic now. I'm just going to run the stop sign so I can get home 5 seconds early. And I deliberate on that. And I say, yeah, that's the choice I'm going to make. And one person there, nobody there, they go straight through, nobody gets hurt. Maybe the cops catch them, but they get them for running a stop sign. The other person runs somebody over. Now, I think it's correct to say, as a moral evaluation of their moral character, they're identical. One person gets punished much more than the other. Why? Because the punishment is not supposed to be a judgment about their moral character. That's why. Because one person killed somebody. Right? We punish people and praise them in part because of the effect they had. One person killed somebody. Yeah. Put them in jail longer. I mean, you know, that's perfectly natural. Nobody ever said that the legal system's point is to make evaluations of moral character. It may come in, but it's not the whole of it. A lot of it is judgments of how much harm you did.
So the punishment fits the crime in this case.
Yeah. So what does that have to do? I mean, that's a fact. And you could say the one person, when there was nobody there, they ran over, they had moral luck because maybe they get a fine, but they're not going to go to jail for 20 years. Okay, fine. I mean, that's an observation. I don't think this shows there's anything wrong with the legal system. I don't know what any of that has to do with free will. In the stated situation, they both made a perfectly free, deliberate decision to run that sign.
Yeah, I think that's
understanding that it involves some danger. I
think that case is considered circumstantial. Like I can't remember the exact philosophy.
I don't know, but that's an example where you say the amount of praise and blame we give somebody is not just a function of our evaluation of their moral character. Yes, that's right. And what does that tell you? Oh, something else goes into it. What else goes into it? Well, the effects go into it. That's what goes into it.
Yeah. And then I think the other one is, I think, constitutive. I can't remember luck. I think it's constitutive luck. So they'll take it further by saying something like, well, one of those people perhaps grew up genetically predisposed to alcoholism, drug abuse, etc., grew up in a rough neighborhood, rough family, and then their decisions are far less deliberate because of these preconceived factors that dictate their behavior.
Well, look, I mean, you have to be clear what you're arguing there.
No, I'm not, first of all,
I don't know what, I'm not meaning you. I mean, one making the argument is arguing that. You could be making the argument, literally, these were not deliberate decisions. As I said, as you do, when you say you do something in hot blood, you're literally not deliberating. You're not sitting down and doing a list of pros and cons, right? You're just reacting in some very emotional way. We do tend to think of that in the law. As an extenuating circumstance. You're going to go to jail less. To say someone came from a bad background or whatever, therefore it's less deliberate. No, it might be even more deliberate. I mean, who knows? The background doesn't speak to the question of how deliberate was it. It's rather this idea of people say, oh, yeah, this is a very bad person. They did it completely deliberately because they're greedy and they don't care about other people and they couldn't care less if they killed somebody and they thought they'd get away with it. But gee, the only reason they're that way is because, and now you list something, because of their childhood or because of their genetics or because it's got to be because of something. It didn't come out of nowhere. Sure, it came from somewhere. So what? Why is that relevant? The person before me is the person before me. You're telling me they're a bad person because they deliberately did this, because they have horrible values and they're a danger to society, put them in jail. Why does it matter how they got that way?
Do you think it's quantifiable, that deliberateness?
It's quantifiable to an extent. I don't mean you can get it down to a real number, but certainly there's a question, a purely factual question. Before somebody does something, what options did they consider themselves to have, right, of actions they could take? If you're driving a car, you better know you could put the brakes on and stop at the stop sign, right? Or you could just not put the brakes on and just plow right through the stop sign. So how many options did they consider and how much time did they spend considering them? And then a big question is what algorithm did they use in making a judgment about which was the best option? Because if that said, look, I am going to count the danger I'm putting other people in at 0, I don't care. I understand that by running this stop sign, I am in principle endangering somebody who might be, in the street. I don't care. Okay, then you're a really terrible person, right? You're just a horrible person. Now, so certainly you can both quantify how much deliberation went in and what was deliberated about, and then importantly, what values were put on the outcome of the deliberation to lead you to a decision. All those things are quantifiable. You can do more or less of it, and it can be more or less good, morally blameworthy or morally praiseworthy.
Do you think these morals or our values and judgments, do you think there is a sort of an ontological framework for this? So there's not just our views on it. It's not relative. It's sort of, there is an ingrained ethics in the universe. So there is this sort of,
I mean, I'm a Platonist about at least certain parts of morality. I think the good, right? I mean, I think, and let me put it in a way that I hope will resonate with people. I think society has made objective moral progress in getting rid of chattel slavery, in getting rid of discriminations in the law based on race, in getting rid of discriminations in the law based on gender, right? I think we are a juster society because of that. We've gotten better. We've made moral progress. That's not because we regard ourselves as better or anything that. That's because those are better. Those are juster, right? Those laws are juster than the ones they used to be. It's not that we've reached perfection, and there's certainly lots of flaws. If somebody says, no, I don't think we've made any progress, and let me give you a contrast. If you ask me, have the visual arts made progress, right? Is painting now better than it was in the 18th century? Obviously, I don't even know exactly what it would mean, and I'm not even sure. I don't think music has gotten better since Bach and Beethoven, to tell you the truth. Has fashion gotten better, right? Does it get better when lapels go from being fat to skinny, or ties, or whatever? I mean, no. These are not the kinds of things where objective progress is the right word. But in case of morality, it is. We have gotten better. Society has become juster. it's unfortunately, there are people who want to take it backwards because it's in their self-interest to do so.
Yes. I was going to say, because I mean, I firmly agree with you. I mean, I think that certain things, for example, slavery, etc., racial discrimination, biases, I mean, it's clear that we've gotten better with this. But then there's also times where you notice how we progress, and sometimes, let's say, the left can go too far, or the right can go too far.
Sure. Everything can go wrong. I mean, to say that there is such a thing as moral progress. I mean, if you think objectively there can be moral progress, you also think objectively there can be moral backsliding, right? Yeah. Things can go too far. It can go in the wrong direction. You could implement policies that, you know, maybe they were kind of thought of in a good-hearted way, but their actual consequences are bad. Nobody wants to say that everything is progress. Nobody wants to say that people don't go too far and then make mistakes. Of course they do. But then it's a straw argument. If somehow somebody says, gosh, here's an argument against your view that there are moral absolutes, that sometimes the left goes too far. Why is that? In fact, it's more evidence, it's more grist for my mill, because when you say the left goes too far, that's supposed to also be an objective judgment, right? It's supposed to be a judgment. The left is now proposing policies that take us morally backward. That can happen. I don't think the left is perfect. Why would I? I mean, you know, you wouldn't have to be, you'd have to not be paying attention if you thought any political group was perfect in what they proposed.
Well, that's Tim, this podcast is called Mind Body Solution, and it explores the nature of consciousness, reality, free will, morality, mental health, and more. I feel like we've covered a lot of those topics altogether. Are there any topics in general with regards to consciousness, free will, morality that you feel you want to just give your last bit on? Is there anything that's been on your mind that you've been wanting to discuss and you haven't?
No, I think I hit the high notes. I mean, people will probably think I said a bunch of things I didn't back up, which it would take another few hours to get into the nitty-gritty of all the argumentation. But I think as far as the headlines go, I feel happy about it.
You feel good about it. Thanks. You know, Tim, it's been an absolute pleasure. I mean, your work is utterly fascinating, and I'll continue to read and delve deep. Thank you so much for joining me.
Okay, let me just, before we sign off, because it's something I need to do, is make a pitch.
Yeah, go ahead.
I've been doing. So I'm right now sitting in Croatia in the lecture room, the Detlef Dur room, which is actually, I'm sure people very nice.
How is Croatia at the moment, by the way? It was great that you're there because it helped with our time zones and scheduling.
And those are actually drawings of the GHZ experiment on the back of the wall.
Oh, wow.
And so this is at the John Bell Institute, what we hope will be the permanent John Bell Institute, but we don't own it. And we're trying with great expeditiousness to try and raise funds and find a way to make this permanent. And so if anybody's interested in this stuff, we need help. We would appreciate any amount of help. And there's a GoFundMe, John Bell Institute, or you can go to the johnbellinstitute.org website. There's a link to the GoFundMe and so on. So
no, definitely, I'll put a link to that in the description as well. No, Tim, it's been such a pleasure. Any final words before we close off?
No, I mean, I've had fun. I hope you have. I mean,
these are always so fun for me. I mean, this is just such a great exploration. Your work is wonderful, and I'm glad you had fun.
Okay, thanks.